Okay, welcome. Let's continue, or let's talk about a series on cybersecurity essentials. This is the art of ensuring integrity. Okay, in this chapter, we will cover the types of data integrity controls, what are digital signatures, certificates, and also database integrity reinforcement and why you do it. Okay, first let's begin with the type of data integrity controls. These are basically hash algorithms, which you've probably seen at web pages where it's a long string of characters, numbers, and what that pretty much in a nutshell, what it means is that when you download something and when you run it against a hash tag program, it should be the same number. But if anything has been modified, changed, saved, fixed, however you do it, it will change, and that way you know that you have downloaded something different or what you have has been changed or modified. The input can be any length, the output can be a fixed length. Hashtag is one way and not reversible. Like I said before, once you get the hash function, any changes and modifications will show as being a change when you do it again. And then, of course, you have two different types of hashtag algorithms you can do. Okay, you've probably seen these. This is MD5 or message IC5 algorithm. This is an algorithm that is commonly used, and you will see the term MD5 algorithm, and it's a 128-bit hash value. SHA, or like I call a secure hash algorithm, was developed by the National Institute for Standards and Technology, and it has actually different strengths. If you notice, MD5 is a lower bit hash value, which means it can be hacked easier than 224, 256, 384, 512. And if my memory serves me right, they're up to 1024-bit and 2048-bit encryption, which is super high. Problem with those is it takes longer to get stuff done and so forth. So you can put in any value you want here, then it comes out here on a fixed value, and this value, like I said, is the one that should always remain the same for the given file information data that you have encrypted or hashed, so to speak. And then within that, there is also something called salting. What salting does is everybody uses the same password over and over again. And unfortunately, the same password will create the same hash value every time. So if anybody was trying to hack your system, they could just look for your hash value and know that was you logging into a system or downloading certain files. What salting does is it will take your password and put in a, I guess you call it grains of salt, so to speak, that change the value of the outgoing hash value. Your database will store both of them, so when you use one or the other, it will pick one or the other as a random value and come out with a different one. That way, anybody eavesdropping will see a different value of your password or whatever you're using at the given point. Okay, the next type is called HMAC, and it's an algorithm that actually puts in a secret key beyond doing the algorithms. It goes one step further than just the assurance by adding an authentication. It will add a secret key that would need to be known on the other end of it. And you have both private and public keys, and we'll be covering that here in a second. This is just like another way of ensuring that what you have has more than one type of algorithm or one type of authentication for whatever you are trying to protect, whether it be plain text or files. Data signatures. Okay, let's go back on the hashtag thing. Whenever you telnet, you actually never want to telnet. You always want to do HSH or secure shell. When you do a telnet, all of your information is in clear text. When you do SSH or secure shell, it encrypts everything using a hash value or encapsulation or encryption. So just be aware of that when you are transferring information to a website or to a company server. Okay, we have digital signatures are next on the docket here. And these are basically signatures that would be like you signing your check or signing documentation. Signatures, be very careful with digital signatures because it has to be unique to the user. They're not reusable in most cases because they are self-destructing, or they will come up with a different hash. That's where the hash comes into play. Easy way of doing the digital signatures is having it come from the source account. Like say you're using Microsoft Exchange or you're using Linux for your authentication. The person that logged in, that signature would be from that user, which in turn should be that person's signature. It is very important when you use digital signatures that they are secure and that you can authenticate the signature on the other end once it is done on it. Remember, signatures should not be altered, so you can run a hash against it. And like I mentioned before, if the hash is actually different than the original hash signature, it has been changed or modified or reused. And then they're coming out with different types of signatures. They have ones now where you have to use two types of authentication, one that you know and actually something that you have to lock it. Or you can have it generate two keys, one private and one public. The public goes out. If the public is cracked, then they would need to know the private, and it's very difficult to get the two. But you'd have to have systems that identify both types. Unfortunately, all keys and all algorithms are mathematical. That's the reason why companies are always fighting hackers, because hackers are always finding ways of getting into these encryptions by doing the mathematic work. Like, I have the capability to where I can get the information on a credit card just by doing math calculations of the account number to get private information on that card. That's something you will not learn in this course, but it's just something that you need to be aware of when you do credit cards and public information type stuff like that. Everything is mathematic based or can be done mathematically. I am very bad at math, so I would not be very good when it comes to doing encryption and encapsulations. But when we come out with our new CSEC courses for our cybersecurity degree, we will be covering more of that in more detail. And of course, there will be more math involved with that. Certificates. Certificates are the little passports or the little keys that you get that say that this site is authentic and it is protected, and that whatever you do over it is confidentiality and those kind of things. Typically, if you see HTTP, that is going to be just a regular web page you go to. If you see HTTPS, the S is supposedly stand for secure, but please be aware that can be easily copied. So be careful. You always want to see either the lock or the key on your browser and click on it, and it should tell you the company and the authentication that is being used with the digital certificates for that website. The structure of the digital must follow standard structures that any entity can read and understand regardless of issuer. What this means is any browser, any company should be able to identify the digital certificate by who it is, the certificate name, the number, the algorithm, the username, validation subject, and other issues that you would see on their extension. All this basically means is everybody should be able to read everybody else's certificate without any issues. Otherwise, you would have problems opening up your bank page or school page or company page because your browser or your particular infrastructure or ISP does not recognize it. And last but not least, we have database integrity. All this basically means is if you've ever taken a database course, you always get this ID number. This is called a unique identifier. This is kind of like what helps protect information on a given row that you have on here. So number 8 would always be company H, Elizabeth Anderson. Number 18 would be company R, Catherine. Number 3, company C, Thomas, Joanne, John, so forth on that one. You can have different types of it. Within the database world, it's called a primary key. That is a key that is used by all the programs that identify with this. It can be used as an identifier when it goes to another table or another source. And all your data must be the same format. So if this is all letters, you can't put numbers in here. If you have columns or dashes, you cannot add different things. That's why when you create a database, they have a design feature where you design each cell to be what it wants to be. Phone number, you could put the dashes in there automatically, so it will not accept letters. Just remember that you can also define your information, so you can put it in order. Use the first check to see if it's a new customer or if it's a different one, just by doing a scan of each column. I would say by default, you do not want to have each column just text. You want to make sure you want to try to define it. If the company name only has 12 characters maximum, make the cell 12 characters maximum, and just customize it to fit as close as you can to the information that you need. And then here, like I mentioned before, here's another way that you can do it. This is an ISBN, which you probably see on books. Characteristics of the size, formatting, consistency, range, and check data or check digit. These are all mathematical, and the way you would do it is you would multiply the first one by 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then your last one is your check digit, which would be the unique identifier for this given ISP. So if you were to do the math calculations and add it up, then you would be able to calculate what kind of is in the field. I mean, there's actually more to that, but this is how an ISP is broken down whenever you see one, and that's where you get the lines that are on the barcodes and those kind of things. But ISPs, if you didn't have this check number, you could have a lot of these be the exact same ISP, and you can't have that, especially if it's an identifier of a product, service, or security type feature. Here's where I was mentioning before about where you would use a primary key here, then this primary key could be used for the order number over here, then this primary key would be used for the customer, this would be for the inventory. So here's your data, here's your records, here's the cost, and as you notice that the primary key here is now your order number, and now your account number is a primary key. So everything can go down per step wherever the item is. Once you link a cell to another table, you cannot delete this without undoing the link on it. So just be careful when you do that. Here's another example of what I was talking about before. This is your primary key on your inventory table, and this is your part number. Your customer now has the name, their account, which is the primary key, and here's the order number that ties into this number. So we know that this customer, Smith, ordered 01020003, and it belongs to the table inventory 01020003, and costs and everything is tied in with this one to this one down here. This happens to be the people, and now your primary key in this instance could be or is your account number, which should be unique to each individual, each company, each person that buys something. Here are some other unique identifiers. Social security numbers, which you should never ever give out. Last 4 digits, never do if you can. Credit card numbers, same thing. This has to be the same type of thing. Like I said, there is a mathematical way that you can figure information out from this. And then of course your email. Try not to have more than 128 characters, which is long, but this should be also identified to unique companies or educational institutions, EDUs, or nonprofits, orgs, or government, GOV, or there's a whole bunch of different dot entities coming out. So if you cannot access a dot entity, that means that your ISP is not supporting it at the moment, and you can get a hold of them and ask them to support dot biz or dot book or dot video, whatever you wish it to be. So just be careful of that when you do that. Okay, I know I kind of went through this pretty quickly, but it is just pretty much I wanted to keep it in basic structure value of what it is without confusing you. Everything has a life cycle. It should be unchanged by anybody. If it is changed, then you'll know by the hashtag. Your password salting keeps people from recognizing your password by the hash it creates, because it would create the same password over and over again. And of course, message authentication code or HMACs. These are the ways of doing it. These tools are provided for cybersecurity specialists to verify the authenticity of the messages and documents. If you've ever gone to a website and if you've seen where you download something, the right next to it that has a hash value, after you download it, you could run that file or that document with a hash program, and it should match what's on the download site. If it doesn't, then it's been modified. We also talked about database. This is covered more when you get into when you do Linux, when you do database and SQL, MySQL type courses. You cover this more in detail on why you need unique identifier, why you have to have or should have primary keys. And of course, you need to make sure that the database is maintained and that you have linked tables, so things cannot just be deleted just because you want to hide that value or you want to hide that item or customer within the given thing. Okay, that's it for this one. Like I said, I went through this pretty quickly, but it is just read the chapter and just go through what hashes are and how they work out. And when we cover our concept later, when we do more CSEC courses, we will cover hashing in a lot more detail and also more authentication, public keys, and private keys. So thank you very much for listening to me today, and have a good day.